In this tutorial, we're going to show you how to take a full 3D model and import it into the software. We're going to show you how to unwrap it, then wrap it again, and then we're going to show you how to create 3D toolpathing for it so you can cut it out on a machine. So this is what we're heading for, but now let's start off by creating a new file. So let's come up to File and Close. So the first thing we're going to do is click on Create a New File, and in this case we are going to make it a rotary job, which is 12 inches by 4 inches. Units are inches. In this case, I've gone for a Z0 position of the cylinder axis because I'm not sure that my material is even all the way around, and so the cylinder axis will ensure some more accuracy in this case. My XY datum is the bottom left, and the orientation I've gone for is cutting along X, so I'm wrapping the Y axis in this case because that is my particular rotary setup. Now if you're unsure about how your rotary is set up, usually you can just tell by visually looking at it, but if you're still unsure, you can always contact your machine manufacturer and they'll let you know for your particular machine if it is along X-axis and wrapping Y, or along Y-axis and wrapping X. But in my case, it's along X, wrapping Y. My modeling resolution is set to very high, and I'm happy with these settings, so I'm going to click OK. I'm just going to tile our views very quickly so we can have a look at the 2D view and 3D at the same time. I'm going to turn on my material block by clicking this button here, and you can see here is our cylinder represented in the 3D view. Now if you look at the bottom left of the software here, you can see the width is 12 inches, and then we've got the height of 12.5664 inches. Now, this is actually the circumference around our job here, and we have our depth, which is actually halfway, or the halfway diameter, which is 2 inches up and down. Okay, so now we actually need to bring in some 3D content to unwrap. So with that, let's go over to the tool on the top left here to import a component or 3D model. And in this case, we're going to use a solid handle.3dm file. Now, it's important to note here that this model is actually one of Rhino's demo models, so we can't unfortunately give this away, but you'll still be able to use the information that we supply here, and you'll be able to take away a lot of information from this tutorial, so you can apply it to some of the models that you import yourself. So with that selected, I'm going to click Open, and we'll get this loaded into the software. So you can see my model's in over here on the 3D view. I'm just going to maximize that so we can have a look at that in some further detail. So let's come up to our view control here, and we'll click on front so we can get a better view of our model. Now you notice there's actually a blue box or bounding box around your model. Now what the software has actually done here is try to place our handle here within our material to get the best use of it and to get the most out of our material. Now with that said, the software's actually done a pretty good job of trying to lay this out, but I think we could spend a couple of minutes here and we could make it look a little bit better. So we can see our model is represented in blue. This red object here is the axis. So this is the actual axis which the cylinder spins around. And you'll notice on the left here we've got this arrow shape. Now this arrow on the left hand side here represents the Z-axis, so where your cutter will be coming down to meet your cylinder. Now when we actually imported the model, because it's a non-native format, the software opened up the Orientate 3D model form, and here we can use all these options to help better position our 3D component in our material. So let's go through this from the top down. So at the top here we've got the imported model type, which is full 3D model or flat model. Now in this case we'll be using the full 3D model, but there are some cases you're going to want to bring in a flat 3D model and unwrap it and maybe wrap it onto another surface. But in our case it's a full 3D model, so we're going to make sure that that one is selected. And then we have the initial orientation options. So if we go through these options one by one, we can see what it does to the orientation of our model. So if I click on right, you'll notice that it puts it into this view, and that's not probably the best use of our material. If I do left, that is just the opposite of right. If I go for front, that's not so bad actually, but I may look at using a different option. So let's go for back. Again, not too bad. Then we have bottom, which is just the opposite of top. And if we go top, I think I want to stick with this option here because I think I can make the use of the most of our material here with this option with some tweaking, but we'll go over that in just a moment. Now, with our rotation by Z-axis, we can increase this by 90 degrees and 180 degrees, and then if we go back to 0, we can go minus 90 degrees and minus 180, but for now, I'm going to stick to the original 0. In the next section, we have the interactive model rotation. Now, it's currently set to XYZ. Now, if I come over to the 3D view here and I right mouse click, I can drag around the cylinder, I can move about and have a look at it in different orientations. Now, if I click on front on the view control over here, we'll go back to the front. But if you notice, if I left mouse click, I can drag this around now freely. So I can move this about freely where I need to place it, and it will respect the new location when I let go of the left mouse click. But I'm just going to Control Z that for now, and we'll have a look at another view. So let's go for X. And again, if I left mouse click, you can see I can rotate this in a circle around our cylinder here. Again, Control Z to undo those changes. And if I go for Z, I can rotate this in Z as well. I'll just zoom out so you can see that a bit better. So you can see how I can rotate that in the Z option there as well. So I'll just Control Z again, but we'll go back to XYZ for the moment. We'll go on our view control and go to the front. I'm going to have a look at now using the Y option to help with our interactive model rotation. So what I'm actually going to do now is I'm going to bring the back of this handle now down and try and hide our cylinder axis. So just left mouse click, and I'm just going to drag this down until I can effectively hide this axis. So I'm just going to drag it to there for just a moment. You can still see a little bit of the axis out there, but if I just rotate the view just a little bit, just to have a look, I think that looks pretty good so far. And you can see in the front view here, it's pretty central for our axis, but on the back here, it's not quite central. Now that can actually cause a little bit of a problem, and sometimes it's just the best that we can do, and sometimes you may have some undercuts that you're going to have to work with, because when the actual software unwraps this, it will try to fill the space between the material and the axis here, and so the fewer the undercuts we have, the better. So for example, if this happened to be a model of a figurine or something like that, you may not be able to position it in a way that there are no undercuts at all, and you may need to work out how to position that to make the best of that particular model. Now the next option on this is the rotation axis movement. Now you notice that if I click with the right mouse click and drag this around, I can't currently move this around too much, but if I turn this option on here, and then if I come round to the back side of it with the right mouse click, if I hold Control and I click on the actual axis itself, what I can now do with left mouse click, that is I can move this axis, and I want to put it in a place where I can get it so that I can reduce the amount of undercuts I'll have. So I'm trying to get it kind of central onto the bottom part of the handle where it will have the least opportunity to create an undercut. So if I just drop it there for the moment, you'll see that it's now moved, and you can see that I've got minimal undercuts there compared to before, where it was up here where we'd have a lot more. And so we look at the front of it, that yeah, that looks way better in that position. So I'm really happy with how that looks in that current position. Now here's another example of when we should try to get rid of any undercuts or try to align our model better so that we can alleviate as many undercuts as we can. It's important to remember that some models, it will just be impossible to do that. By the end, you may end up having to remove it by other means, maybe after the part is finished, or by breaking up your part into several different pieces. But we want to try our best to try and hide that rotational axis inside the component. So let's have a look at doing that. Now with our table leg here, there's a bit of a dip here. Now that can cause some problems for us because that could lead to a lot of undercuts, and we'll get a pretty strange looking model in the end. So by using a combination of our interactive rotation and moving our rotation axis, we should be able to get rid of most of that. So first of all, I'm going to set the interactive model rotation to Z. And I'm just going to left mouse click on the model here. I'm just going to tilt this up just a little bit until that back end is kind of touching the axis, but so that the front end of the leg or the top end isn't coming out of the rotation bounds there. So about there is about right. And then what I'm going to do is I'm going to drag this around and have a look at it. And I'm actually going to have a look at changing that rotation axis movement. So let's turn that on. Let's put this view back to the front here. So we can use the options here for the top on the view control, and we can hold Control on the keyboard, left mouse click on the axis, and we can drag it down. Now what we're aiming to do is effectively hide the axis in here, but what we're not aiming to do is have it come through the kind of smaller or narrow bit of the leg there. Now what you may have happen is if you look at the kind of back end here, you can see it kind of poking through. That's not what I want. So let's lift that back up again and we can see it now popping through the kind of midsection of that dip there. So that's not what I want either. So I think about there seems correct. Now what we'll do is we'll turn our rotation axis movement off, and then we're just going to drag the view around with the right mouse click, or you can use the view control at the top here, and you can click on the various options on the view control. I'm just going to have a look at what this looks like in the various views. Now what I'm looking out for here is, for example, on the back here, I don't want to see any red poking through from the axis. So right now that looks pretty good, and then I can look at it from underneath as well, and there's nothing poking through there either. So we've hidden that axis, or we've buried that axis pretty well into this leg piece, and you can see how powerful the view control is, because you can just simply click it and move where you need to for your view. And just one more thing to point out, that's because of where our rotational axis currently is, and the way that your CNC machine will work, any details that are close to your rotational axis may have a hard time getting cut. So just keep that in mind when you're designing a part with the rotational axis in mind. But with that covered, let's go back to our original model. And now that we're back onto our original model, we need to look at the model scaling form here. Now, right now this model is very, very large. And chances are that when we imported this model, it was done so in units. And now, if we change the model units to millimeters, for example, you notice it's around 5 inches, and then the length is around 12 inches. Now, this will be right, but what this does is it actually indicates that it's taking the inches from our job setup form. So currently, because our job is set to inches, it is now displaying that this is now in inches. So this is accurate, even though we've selected the millimeter option here. Now, if you look over to our 3D view, you'll notice that we now have got a red cylinder as well as a blue cylinder. So the blue one represents our bounding box, and the red cylinder in this case actually represents our material. Now this is where our model scaling comes into play, because what I could do is set the values here manually and change these values. Now you notice that I've got lock ratio here checked, and what that means is if I change this value will also be affected. But underneath that, you can also see I have the option here to scale model to fit material. So I want to click that because I want to scale my model to fit in the material. And you can see what the software has done is it's put it inside of the red cylinder here, so it's fit my model with inside of that that material. So what I actually want to do is leave a little bit of material behind as a bit of safety, just so I've got a little bit of material to play with. So I'm actually going to change this down to 8, and you can see now I've got a bit more material on the top and the bottom here, and at the front and back here to play with. So I'm just being extra safe, extra cautious, so I can actually cut this out, you know, with a little bit more room for error if I need to. And if I increase it to 9, for example, you can still see I've got a little bit more room on either end actually. So I think I may actually end up sticking with 9 for this one. So let's just pop that back into view, and with that we can click OK. And you can see here this is the end result. So this is our handle in the 3D view, and you can see it's modeled really nicely and it's turned out really great. You can see that if I spin this around, it doesn't look like we've got many undercuts to deal with at all, so it looks pretty good from where I can see. So the other thing I need to point out here is if I come up to the unwrap option here, so you can see that when I unwrap this, that as I mentioned earlier, we'll be wrapping the job in the y-axis. We're cutting it along the x-axis, but we're wrapping the y-axis. So this is what the job looks like unwrapped. So what it's actually doing is it's taking the job and kind of making it flat, then wrapping it around the y-axis to create this handle. And this is what we'll be doing on your CNC machine, because the G-code moves in this case will be going Y to A. So the Y moves will become A moves, which will in turn allow it to wrap around and create this rotary project, which allows it to now look at a lot more like this. So you'll get this handle instead. Now many of you may be thinking, and rightly so, if we come to cut this as is at present, this is just going to fall off the machine because there's nothing holding it to the edge of the material here. There's no tabs. So how do we look at adding in tabs? Well, what we need to do first is we need to go over to our components tab on the left hand side here. Now you can see under our components we've got 2 here listed. We've got the handle and we have our 0 plane. So what we're going to do first is switch the combine mode of our handle by right mouse clicking and going to merge. And then we're going to go to our 0 plane and we're going to right mouse click that, and this time we're going to go to properties. And then what we're going to do is actually add in a base height here, and I'm going to add in a base height of 0.25. And if I hit space on the keyboard, that should take effect. You notice now we've got a tab coming out of the other end here. So what it's done is wrapped it around and created our tab for us there. And if you want to make that a little bit smaller because you don't want to take up that much space of your handle, you can do so. But in this case, I'm okay with it being 0.25 inches. I don't need to be any larger than that, certainly. And I think 0.25 is what I can get away with. And I can still finish that up pretty nicely. So with that now set in place, we have our tab, so we can now safely remove our handle from our cut when the machine comes to cut it. And the machine will know where the tabs are currently, so it will come down and cut around these and not cut these off. So we can close out this menu and we can go over to our toolpath menu by clicking this button on the top left here, and let's look at having some toolpaths made for our rotary project. So as with every toolpath, we check our material setup first. We go to material setup and our diameter is 4 inches, XY date in bottom left, Z0 off the center of the cylinder, as we don't know if the cylinder is even all the way around. Now in this case I've got a small gap outside material, and that's because I want a bit of margin for error, because as I mentioned with the cylinder here, I'm going off the cylinder center because I don't know that my material that I'm using is even all the way around. So having a little bit of a gap outside the model gives me a little bit more margin for error. So I've got a bit more material to play with should that be an issue. My clearance and plunge settings are safe and sound for my machine, as is my Z-gap by material, but do run some tests on your machine to make sure they're appropriate for your machine. With that I'm happy, and I can click OK and then have a look at making my very first toolpath. And that first toolpath is going to be a 3D roughing toolpath, which is this one just here. So with our model, we're going to choose the model boundary. A tool in this case is going to be a 1/4 inch end mill. And in this case, I'm actually going to change the path step for this job only. So I'm not going to do it in the tool database because this will change the record in the tool database for all my settings. Whereas I only want to do it for this job only. So I can click this button here to do it for this job only. So we're going to change the path step to 0.25. And I'm going to keep the step over as is. I'm going to click OK. That's now been changed. I don't need a boundary offset in this one. I am going to leave a little bit of a machining allowance so that there's some material for our finishing pass to remove, as well as to account for any chipping. We're using a Z level strategy. We're doing profile last, order level by level. The rasp angle we're not going to change, but I am going to just call this one 3D roughing, and then we can click calculate. And so you can see we're presented with our toolpath here on the left hand side, and we can look at previewing that. So let's click on preview selected toolpath to see what that's going to look like. You'll notice here that the software has actually unwrapped this job and is machining it as a 3-axis job, and then what it's going to do is actually wrap it around again. So you can see, as we spoke about earlier, that the software is using wrapped rotary. So it's first machining it or creating it as a 3-axis job, and then wrapping it around the axis that is specified in our job setup form, which for us was the y-axis being wrapped to A. So in a moment here, when this is all finished, this axis will be wrapped, and we'll see what it looks like as a wrapped roughing pass. Now that is what I expected to see. It's quite an interesting design so far, but that is what I expect to see because it's a roughing pass, and the roughing pass is there to remove the majority of the material, but not all of the material. And the finishing pass, which is our next toolpath, will remove the remaining material. So let's have a look at that, shall we? So let's go over to the finishing toolpath, so 3D finishing toolpath. In this case, I'm going to remove this tool, but I am going to use a 1/4 inch ball nose. And I'm actually just going to increase the step over to 10%, and then I'm going to just quickly double check the rest of the settings. I'm happy with these. I can hit apply, click select, and that's my ball nose tool selected. And my machining limit boundary is going to be the model boundary. I don't need a boundary offset. As for the strategy, I'm actually going to switch this one to raster. Now, an important thing to note here with the raster angle is that I'm not going to change this, but to let you know what it actually does. In this case, what the raster is going to do is going to go across our material, and then it's going to rotate the step over distance, come back again, rotate the step over distance, go back again, and that's how it's going to cut. Now if I change this to 90 degrees, for example, what would happen in this case is that the tool would come down in the Z-axis here, and it will do the full rotation for the cut, move along, full rotation for the cut, move along, full rotation. So in this instance, I'm going to go for a raster angle of 0 because I don't want the 90, and I'm just going to call this one 3D finish. We can click calculate and then have a look at what this is going to look like. So you can see here we've got the blue lines to represent our toolpath, but let's have a look at what the preview does with this. So let's click on preview selected toolpath, And again, you can see what it's done is that it's unwrapped the job and that it's cutting it as the 3-axis job effectively, and then it's going to wrap it again. But you can see how much smoother we're getting there. So you can see the roughing pass did its job in that it removed a lot of the material, but then left some material behind for the finishing toolpath to clear it for us. And you can see the tool is doing a great job. The bore nose is really getting in there and getting some of that detail out. So you can see just how nice it's going to turn out. So we'll just let the toolpath finish up here, and then we can take a look at our wrapped handle. And there we are. It is now finished the toolpath, and you can see it's left the tabs intact. So they are all there ready for us to then remove it safely off our machine by cutting those off instead of it just being floating there with no tabs. Now at this stage you can look at your preview and see if any parts of your model need addressing or if you need to adjust your toolpath in any way. But if you're happy, this is where you can save your toolpaths out. And in this case, because as I mentioned earlier, this is a demo file from Rhino, I will not be saving that due to the license agreement, but I highly encourage you to get your own models and experiment using the wrapped rotary abilities in the software. And that brings us to the end of this tutorial, but I hope you have enjoyed it. We do have several other tutorials on wrapped rotary machining, which include saving out toolpaths for that. So if that's something you're interested in, please do go look them up, but we look forward to seeing you in the next video.